So you saw the video and had some time to think about which person did the most work and thought about what kind of machine or device could replace each of them. The typical examples for what would replace them are, in the case of Deb, it might be a shelf or a hook on the wall. In the case of Zayden, if we imagine a frictionless world, it could be wheels on the box or a conveyor belt that says conveyor belt. And in Addie's case, the typical example is a forklift. Usually I do the demo in class with kids lifting tables, or lifting chairs, or moving chairs, but Addie wasn't going to be able to put a chair up on the table, so we used the boxes. When you thought about batteries or fuel or whatever was going to power these things, a shelf could go forever. Wheels or a frictionless conveyor belt could go forever. Whereas the forklift would need fuel or batteries or somehow would need to be repowered. And so, thinking about that, the only person in this scenario who actually did any work is Addie. So Addie did work. And what we want to think about now is, okay, so what about what she did was different from what Zayden and Deb did? And how is it that she's the one who ended up doing work? So, what are the conditions for work to be done? They all had to exert a force. Deb was going to get tired holding that box. It's even more noticeable when it's a chair instead of a box. Zayden had to exert a force or the box was going to fall to the floor. And Addie had to exert a force to lift the box. So in all three cases, there was a force exerted. In the case of Zayden and Addie, there was movement that took place. And that's what eliminates Deb from the scene, is there was no movement in her case, and so a simple shelf or a hook would take care of that work, or of that task. But in both Addie's case and Zayden's case, they each exerted a force, and there was movement of the object in each case. The difference for them is, in Zayden's case, the force he had to exert was upward, and Addie was also upward. But the movement, Zayden moved sideways. Whereas in Addie's case, the movement was upward. So the difference is that not only do you have to exert a force and have there be movement, but there has to be force exerted in the direction of motion. And if there's a force exerted in the direction of motion, then we have work being done. So that's the situation that's necessary in order for work to be done, is that there's a force exerted in the direction of motion. The next question we would want to answer is, okay, this seems like something that we might want to quantify. So how do we calculate work? How do we quantify amount of work done? And this one we can just do intuitively. We can say it depends on force exerted and that should say on, depends on force exerted and on distance moved. And probably you would guess if Addie was lifting a box twice as heavy, it would take 2 times the force, and I suspect you would think it would take 2 times the work, or that she would have done 2 times the work. Or if she lifted it twice as high, she would do twice as much work. And so we can use our friend the infinity fish and say that work, and the symbol for work is W, is, sorry, I'm supposed to do the fish, is proportional to force, and work is proportional to distance. Put them together, work, and that's a capital W, is proportional to force times distance, which means work equals some constant times force times distance. And conveniently, as was in the case of the definition of force, the units of work are newtons times meters, and so this constant of proportionality can just be 1 because we've defined the units in a useful way. So work is equal to force times distance. And that's the formula. And so if you exert a force of 3 newtons through a distance of 2 meters, you've done 6 joules of work, 6 newton meters of work. But a newton meter is also a joule, which is symbolized with a J. And we'll talk about the fact that that's a familiar unit from somewhere else in your science background in another setting. So for now, the formula for work is force times distance, and you're going to watch another video that's going to show a little problem with that in just a moment. So I'm going to pause us out of here, and you can go watch the